The conservation of information paradox that I was referring to with the preservation of an A note, 440 hertz, anywhere you broadcast it, is not taught or seen through experiment that I'm aware of. There must be an interesting innate quality inside a radio or television wave, and possibly all the waves in the electromagnetic spectrum, that allows this picture, sound, frequency, and wavelength to be preserved and not be redshifted, blueshifted, or perturbed in any fashion, and is not dependent on speed, distance, or direction where the wave is sent. Comparatively to the information retention paradox of redshift, a similar concept of time dilation is publicly accounted for and commonly taught in schools and is held in high esteem in cosmologist circles. The example of GPS satellites having to adjust their clocks due to time dilation is often given. Another rationale to this observation of time dilation is that clocks do not agree because of distance differentiation. It is the opinion of Albert Einstein in the Theory of Special Relativity that the dilation in time is caused by the difference in distance the light travels in the same amount of time. If you compare two light clocks, figure 1 and figure 2, one at rest and one moving in an expeditious manner, the light clock that is moving quickly will show an M-like path with its light traveling a larger distance with respect to time, compared to the observer at rest whom would just have an I path. Granted, many scientists view redshift and blueshift, and their effects have been observed worldwide many times in the galaxy by many projects and sky surveys. They have exact measurements of the body getting redder as it moves farther and farther away. According to Wikipedia article about redshift, while it was long believed that the expansion rate has been continuously decreasing since the Big Bang, recent observations of the redshift-distance relationship using type 1a supernova have suggested that in comparatively recent times, the expansion rate of the universe has begun to accelerate. However, my refute to that statement would be that the observed effect of the expansion rate getting larger could be a function of position in space, angle orientation of the observer, and atmosphere. For example, the observations of interstellar astronomy of a visible spectra can appear redder due to the scattering process in a phenomenon referred to as interstellar reddening. Interstellar reddening occurs because interstellar dust absorbs and scatters blue light waves more than red light waves, making stars appear redder than they are. This is similar to the effect seen when dust particles in the atmosphere of Earth contribute to red sunsets, according to Wikipedia Interstellar Reddening. Also, observations you make in the bluer part of the spectrum might be affected differently than observations in the redder part, as dust grains of different sizes have different sensitivities to a variety of wavelengths. Ethan Siegel, Forbes.com. Similarly, Rayleigh scattering causes the atmospheric reddening of the sun seen in the sunrise or sunset and causes the rest of the sky to have a blue color during the day. This phenomenon could be seen in the universe and recorded by astronomers mistakenly as blue or redshift. A blue sky and an orange sky on Earth is most likely the relationship of the observer and the atmospheric angle of view. For example, if the sky is orange, then it does not necessarily mean that it's any farther away from the observer. It's just a different angle orientation with respect to the atmosphere. This concept, when applied to CMB's data sets, could potentially skew data into a larger age since the Big Bang. The cosmic microwave background photons easily scatter off electrons. Thus, photons wandering through the early universe just as optical light wanders through a dense fog, according to NASA. This natural process of scattering can both affect any light, including redshift of starlight and the CMB and can be easily observed here on Earth. Observations of blueshift. Along with the recorded redshift that cosmologists have diagrammed, there have been other recorded observations of blueshift that are far more rare. They would show that instead of formations moving away as Big Bang theory would predict, there are also movements toward our observing telescopes. This is a contradiction in the formula for the commencement of the universe from one point in singularity. Below are a list of some of these observations of bodies exhibiting blueshift from Wikipedia. The Andromeda Galaxy is moving toward our own Milky Way galaxy within the local group. Thus, when observed from Earth, its lightning is undergoing a blueshift. Components of a binary star system will be blueshifted when moving towards Earth. When observing spiral galaxies, the side spinning toward us will have a slight blueshift relative to the side spinning away from us. Blazars are known to propel relativistic jets toward us, emitting synchrotron radiation. Nearby stars, such as the Barnard star, are moving towards us, resulting in a very small blueshift. Although the recorded number of redshifts outnumber the amount of blueshifts, the Andromeda galaxies, blazars, and the Barnard star coming toward us as a blueshift are evidence of some material causing gravitational attraction, pulling massive stars by gravity, or multiple Big Bangs, another in a direct opposite galaxy pushing a part of a universe towards us. Another explanation, the most likely, is the steady-state theorem, in which stars come into existence through vibrations in the ether without a central Big Bang. If true, it does undermine a current scientific institution that galaxies are moving away from us. An international team of astronomers led by Christopher Colles, professor at astrophysics at University of Nottingham, have found that the universe contains at least 2 trillion galaxies, 10 times more than previously thought. Current astronomical technology allows us to study just 10% of these galaxies, and the remaining 90% will be only seen once bigger and better telescopes are developed, according to physics.org. According to Wikipedia, astronomers have found that around 100 galaxies are moving towards us. The galaxies M90, M86, and M98 are all Virgo clusters and all show blueshifts. SpaceAnswers.com. There must have been some force responsible in the above observed blueshifts, but that force is still unknown. In the above citation of a blueshift example of a binary star and spiral galaxy that is in procession towards us, there's a large percentage of binary stars that are in each other's orbit and present in the universe. If you go out and look at all visible stars in the night sky and ask how many of those are binary, the answer is most of them, says study author Charles Latta of Harvard-Smithsonian Center for Astrophysics. According to Wikipedia, research over the last 2 centuries suggests that half or more of visible stars are part of multiple star systems, otherwise known as binary stars. In regards to spiral galaxies, nearly 70% of the galaxies closest to the Milky Way are spirals, space.com. If these statements are true, then all the binary stars and spiral galaxies making up most of the universe should have an equal amount of redshift and blueshift parity, depending on precession in the relationship to Earth, if rotating equally. When researching this paper, there seems to be a lot more citations of redshift datasets than blueshift datasets from sky surveys.